Uniper Energy Storage. How does underground gas storage work?
Gas storage makes a vital contribution to a secure energy supply today as part of the energy transition and the future energy world. Despite this, they are largely unknown. We would like to give you a look behind the scenes and use the example of one of our largest gas storage facilities in Etzel to show you how an underground gas storage facility works.
This video takes you through the process of gas injection and withdrawal at our Etzel gas storage facility in northern Germany. Here in East Friesland, there are large underground salt formations, which offer ideal conditions for the storage of natural gas. During the summer, we inject gas for our customers, and when it gets cold and demand increases, these reserves can be made available for distribution to end users. The lines show how the gas flows through the storage facility. By the time the natural gas reaches the storage site, it has already traveled a long way. When it enters the station, it first passes through an inlet filter, which removes entrained impurities such as dust and tiny particles. From here, the natural gas is piped to a metering station to determine its quantity and quality, including parameters such as the gross calorific value. Now the gas is ready to continue its journey through the on-site piping system. Before the gas enters the caverns, we increase its pressure. These buildings house electrically driven compressors with a capacity of about 54 megawatts. The station has 3 compressor units, comprising a prime mover, a gearbox, and a compressor. In order to be able to store as much natural gas as possible, the compressors raise the pressure of the gas from the pipeline pressure to the storage pressure. This pressure increase allows significantly more gas to be stored in the same space. Compression generates heat, which means the gas heats up during the increase in pressure, so it must be cooled down before it can be injected into storage. Coolers remove the heat generated during the compression process. After cooling, the gas is piped to the caverns. The wellhead is the connection between the above and below ground parts of the station, acting as a kind of lock for the gas to the reservoir. The elaborate design ensures that gas storage is reliable at all times. In order to ensure well safety, the entire installation is equipped with several safety valves. The last downhole safety valve is located at a depth of about 50 meters. In the unlikely event of damage to the above-ground system components, this valve will close automatically to keep the gas safely inside the cavern. The gas is stored in large caverns, which are artificial voids leached into salt rock, where the gas is kept for several months. Each cavern is larger than the Eiffel Tower. In winter, when temperatures are low and natural gas demand is high, the gas is withdrawn from storage. Since the gas has absorbed moisture during storage in the cavern, it has to be processed before being transported to the end user. The gas then passes a so-called water separator, which separates liquids from the natural gas. After drying, the natural gas is preheated because it will cool down quite considerably when depressurized to the lower pressure level of the transmission system. The gas is heated by a heat exchanger. The heat is provided by the boiler house. In the absorber, the natural gas is dried using glycol. The glycol is piped to the regeneration unit, where it is treated so it is prepared to bind moisture from the natural gas again. Before leaving the station, the gas is piped through the metering station for flow metering and gas quality measurement. All of these processes are monitored and controlled from our on-site control room, which is manned around 24/7 to ensure safe storage operation. The gas is now ready for transfer into the high-pressure transmission pipelines. These pipelines are part of the integrated European gas pipeline network, and together with the underground gas storage facilities, play a crucial role in ensuring security of supply for Germany and Europe. We will continue to ensure what will eventually be a carbon-neutral supply of energy by helping to store renewables in the form of green gases, such as hydrogen. In this way, we are making an important contribution to the energy transition. Uniper. Empower energy evolution.